All right. As I told you last week, these first couple lessons this month are coming out of uh, a text that I'm not used to preaching out of, and that is Tyler's biology book. But as we continue on in this series of lessons about having our faith affirmed, the typical strategy that I take is to just argue for the proofs that indicate that we have a God of the universe, and that God uh, demonstrated himself, made himself known, manifested himself in the Bible. But what we're doing in these lessons last week and this week is I'm helping you to see the things that your kids are learning in their science classes. And sadly, it's not just their science classes, because this stuff rolls into other course of study as well. But what we're going to do, like we did last week, is I'm going to read a couple sections from this book. The way we're going to do it this morning is I'm going to read a section. We're going to go through a little bit of some slides to give you a more biblical way of looking at it. And then we'll read a second section, and I'll finish up with some slides, and that will be your lesson. So this is from page 302. And again, it's called Modern Biology, California. Maybe biology is different in California than other states, but this is Modern Biology, California. And so from page 302, it says this: a fossil is the remains or traces of an organism that died long ago. Fossils of many kinds of organisms can be formed under a number of different conditions. Fossils show that different types of organisms appeared at different times and places on Earth. Some fossils are of organisms that have become extinct, meaning the species is no longer alive. Fossils are among the most powerful evidence of evolution. Okay, you guys get that? Let me read that one more time. Fossils are among the most powerful evidence of evolution. Now, I'm going to skip over to another part that's also about fossils. This is on page 303. It says, however, the fossil record is an incomplete history of life because not all organisms have left fossil evidence. Okay, so it's indicating that there's fossils that we can find, but then that we don't have examples of all fossils because the record is incomplete, and it goes on to explain why. Most fossils are formed only by rare events. It's interesting. Most fossils are only formed by rare events. For example, a fossil could form if an organism died in a place where it did not fully decay. Listen to that again. For example, a fossil could form if an organism died in a place where it did not fully decay and where rock later formed over the remains. Does that make sense what that's saying? Before we argue with it, let's just, right? Because I will tell you, that's a part of the science book that I agree with. That fossils are formed by rare events, not common ordinary events, but by rare events. And the rare event needs to be such that the animal that is fossilized, or the organism that is fossilized, it has to happen so rapidly that it can't decay prior to being fossilized. Make sense? Okay, that's from Tyler's biology book. John Paul's so much slicker at this than I am. So what we'll be talking about today, we'll be talking about fossils, and we'll be talking about radioactive dating. And, because it's Valentine's Day, talking about dating is boom, boom. All right. Okay. So see this animal, the coelacanth fish. This. Tell me, there we go. Emma and Madison are trying to tell me scoot over. Okay. Yeah, you guys see this animal, right? So this is a weird looking fish. And when they found this fossil and they dated it, and basically we'll talk about this in a little bit in a second, but one of the ways that they date fossils is when they look at the Earth's surface and the Earth's crust, wherever they find it, they have a name and a time frame for that particular crust. And so like I'll show you in a second, but if you saw the movie or movies or whatever, Jurassic Park, that's because the Jurassic age is this made up age that evolutionists have. And so they will date the fossils based on where they fall in that strata. Okay, got it? Like so strata, 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 and then here's an animal. And so this fish is supposed to be 65 million years old. And that number should stick in your mind because that's like what they date dinosaurs being, yes? Except for example, monkey form when people started finding these fish. So this thing is this thing, and now they find them, catch them, and they just still exist at all sorts of places. It may be that this fossil could have been 65 million years. It could have been, I don't know, 100 years ago or whatever. Okay? Got it? So that's a problem because they're never going to tell you that, right? This fish, prior to finding this, had a story about it that included it probably grew legs at some point, walked on land, went to college, got a degree in biology, all sorts of stuff, until they started finding the real life thing around. And as I told you during our Bible study, the problem with what they do with ocean features or things under the water is there's so much water on the planet that there's so much life that we still have yet to find. Okay, and so they make up stories about things until we find it in reality. This, okay, can you guys see my little cursor? Yeah, no, yeah, it's a little white cursor. Okay, see this is like a shoe, and this is this is not Adidas, this is not Nike. Okay, these are shoes though. And see this little thing down here? It's so little that they blow it up here. So this is not a new thing. This is a blown up version of this. This little thing is a trilobite. And what this would indicate is that whoever made these fossilized footprints had squished a trilobite or stepped on a trilobite, or whatever, right? Like that's what we do, or we squish things. Okay. But this trilobite and this human who made these footprints, it happened at the same time. Okay, that's what that would indicate. That's what the evidence would indicate, right? But the problem is, you guys see this fancy thing? See down here at the bottom? Okay, so over here we got these years, and this is really bad, but these are like billions of years, 2.5 billion, and then you get into the hundreds of millions of years. Okay, see this little thing I'm circling right here? This would be a trilobite. So according to what your kids would learn in school, the trilobite was way down here. Now see this right here, this Jurassic? Yeah? So they think this is when dinosaurs, see the little dinosaur fossil? See, this is dinosaurs. So according to this diagram, trilobites were long time ago? Like way long time ago, way before even the dinosaurs. And the dinosaurs are at least 65 million years before us because see, we're way here at top. I don't know, Renee, Roger, what kind of truck this is, but we're way up here, and the dinosaurs are way down here, and the little trilobite is way over here, except for, somebody stepped on one and got fossilized. Sorry, we don't want to tell you that in our science books because it sort of blows up the idea that trilobites were down here and us were up here. In between us were these dinosaurs. Okay, so when I talk about the strata stuff, so this is the Grand Canyon. Norman, you've seen this? Yeah. Yeah. Okay. Colorado River in this picture. See these layers? Can you sort of see like how it looks like there's like a cake, All right. So according to evolutionary thought, oh, just kidding. You can't see that yet. According to evolutionary thought, those layers look like this. Okay, so these layers aren't, 20 years apart. They're hundreds of millions of years apart in some cases, bottom to top, right? Hundreds of thousands of years in between, yes? right? Like layer. So just imagine you made a cake really slow, okay? Like really slow. So you make one layer today, you come back when you're in the nursing home, you make another layer. Okay, you give me like, and then you pass on to your great grandkid, it makes another. Like, does that imagery make sense? Right? So evolutionists teach that these layers happen over epochs of time, okay? Millions of years, or at least hundreds of thousands of years. Got it? However, remember how I showed you on that first slide, there's these animals like the trilobite and dinosaurs? So they think all these layers have fossils that only live in those layers because that's when they existed. Except for you have marine creatures, mammals, birds, all found in the same layers. So when you back up and you see these animals nice and neatly in their little categories, the problem is they intermingle within these categories as well. But it doesn't make for a nice picture because then it forces you to conclude some things that otherwise you don't want to conclude. Did that make sense? Now, does that make sense? Right? So this is how your parents want you to organize your room, kids. Like they want you to put this in this drawer and this in this drawer and this in this drawer. But is it possible that sometimes your socks end up in the underwear drawer and the shorts end up in the shirt drawer and angel, right? Because you sort of mix them up a little bit and you just throw stuff because mom says clean your room or you don't get ice cream. You just grab stuff and start throwing it into stuff. Well, the real geological record looks more like your bedroom drawers than it does this. It's not all nice and neat and tidy that the strata makes sense, where it's just like this and this and this. It's all sorts of difference. Second point on this slide is rock layers are folded in several places around the world. So let me ask you this question. If I give you two things to fold, a piece of paper and a ceramic plate, a piece of paper and a ceramic plate, which would be easier for you to fold? Right? Obviously the paper, right? Because it's pliable, it's bendable, okay? Versus the plate. If you tried, like, you know, you're Renee and you're super strong, and you try to fold, no, right? Your dad's super strong. If you tried to fold a plate, what would happen to the plate? It would just crack, it would snap. It wouldn't fold, it would just snap. We have places all over the world where the Earth's crust is folded. But wait a minute. If this bottom part, can't get my cursor, where's the cursor? You can't see the cursor. But if the bottom part was millions of years before the top part, it would be pretty hard before the other layers came on top, right? So how did it fold? Well, next week we'll talk about what could have made it fold, right? But we have this. You're not going to get taught, your kids are not going to get taught this in their biology class, because this doesn't speak to layer upon layer with hundreds of millions of years in between. This speaks to a rapid layering of the cake when it could bend because it was nice and fluid for some time. There are fossils that capture, so you see fossils that capture animals giving birth, that capture animals in the middle of a bite. There's a famous one where you see the animal that still has vegetation in its digestive tract, right? Boy, that, you know, I mean, sometimes like we eat cheeseburgers from Elmer's and they may stay in there for a while, it feels like, but probably not hundreds of millions of years, okay? So if you get fossilized with vegetation still in your digestive tract, it probably happened rather rapidly. Then you get some crazy fossils that exist in the fossil record of bees, jellyfish, and it's like this impeccable detail. And I don't know about you, it's hard to catch a bee, much less fossilize one. And yet we've got that in the fossil record. Then you have these kind of things. I really wish I could get them. Can I make that go away? I think I can make that go away. Boom. All right. So remember these layers, like I showed you in the picture of Grand Canyon, all these layers? Okay, again, supposedly hundreds of millions of years and all this stuff in between. But what we have here in the middle of this is a tree stump. You have a tree stump that cuts down through multiple layers. That's one old tree. Or those layers are not nearly as old as one might think. And it may be even more possible that the tree got fossilized at the very same moment that the layers were laid in something like, I don't know, a worldwide flood. Think of what just happened in our recent storm, right? You know, fences blew down, okay, trees. My poor neighbor ended up with some of my palm tree in his yard, okay. Well, just imagine what would happen. Not only 40 days and 40 nights of the most torrential rains ever, but also the Earth's core opening up. You think some trees started flying around and floating around and whatever, and you think they might have gotten caught up in the rest of the dirt and the debris and the mass of mudslides that would have happened in the flood? I think it's very possible that that's how that tree ended up like that. Not only do we have trees, there's not a good picture of this, so I'm using this drawing. This is the fossil remains of a whale up like this, upside down, in the same type of idea where it's covering multiple layers. I'm so thankful that that whale decided to lay there like in sunbathe for long enough to fossilize. I give you this example because think about this. Do we not know of whales and other sea mammals that get caught? They call them getting beached or whatever they call it, you know, when they get stuck on land, right? And what typically happens in something like that is they come above shore, on shore, when it's like high tide and then the tide goes out and they don't quite make it back out. Okay, that's, you know, you get these awesome stories. People come up and they try to help them get back out and they, you know, whatever. Okay, but it happens quickly. Like in a couple hours. It doesn't happen over hundreds of millions of years. What a dumb well this is. That's like, you know, hey, the water's receding very, very slowly, but I'm not just going to swim out into the water. I'm going to stay stuck on land and become fossil. It's not a rare occasion. This picture is taken from Chile. Did I get the pronunciation right? My family hates when I try to speak anything but just straight English because I sound too white. But Chile has a whole thing of these whale fossils, right? So this isn't the only dumb whale. Chile's got a bunch of dumb whales that got stuck on land over millions of years and fossilized. If you just think of locally, we have here in Kern County, we have what is called Shark Tooth Mountain. It's called Shark Tooth Mountain because guess what? There's shark teeth on the mountain, right? Those stupid sharks, they got caught up on a mountain over millions of years of the waters receding, or the waters threw them up there and maybe even killed them in the process, right? Because, you know, they could bang their heads on things like mountains. And then they died and they fossilized rapidly when the waters receded. Okay, and they were covered up and all this stuff. You get me? So you have tons and tons of evidence. Remember, I read to you from this book, yes? That this book tells you that fossils are one of the primary proofs of evolution. I would argue fossils are primary proof of the creation story and the truth that we find in the Bible, in particular Genesis 6, 7, and 8 that we'll talk about next week. Okay? All right. Fossils, yes? Okay. And for anybody who has atheistic leanings, whether you're watching this right now or later on, notice I've used no scripture yet to argue for the existence of my God. Because as I've said to many of you over the years, I don't have to argue from God from the Bible, as I point to a biology book. I don't have to argue for God from the Bible. I can easily argue for God from a biology book. All right. Now, there's this other part of this chapter. It says, for certain rocks, scientists can estimate the time since formation. Okay, in other words, what they can say is they can date how old the rock is. Okay, all right, and they call this the absolute age of the rock. And what techniques do they use? As it says here, by techniques such as radiometric dating. Radiometric dating. Now, this is where somebody like Denise goes, like, you know, she's like thinking like, okay, what am I going to do afterwards? Okay, but that's what they do to your kids in school. They say something like radiometric dating, which is like, whoa, you know, okay, that's crazy. All right, so what we're going to do is we're going to quickly explain to you how radiometric dating works and why it's a bad way to tell the age of anything. So if I were to show you some partially melted ice, and I were to ask you, how long have those ice cubes been there? Right? Like, let's say it just, you know, I took something like this and I put some ice cubes, and you could tell that there was some cube, but there was also some liquid, right? And I said, tell me how long they've been in there. Would you have a clue? You wouldn't have a clue at all, right? Because there's all these things that matter. So for example, if you don't get what matters, does it matter whether or not this is outside in the sun in 100 degrees? It may be seconds for that to happen. Okay, but you know, guys, have you seen the temperatures in Texas? It can be like 7 degrees. Okay, and 7 degrees, ice cubes, you're wondering how it's melted at all, right? You know what I'm saying? So does the outside temperature have any impact on what stage this is in and how long it may stay in this stage? Yes. So watch me. You know nothing by looking at it today. You know nothing. You would have to know all of these other factors to be able to have some chance at saying, oh, those ice cubes have been there for whatever night. Now, let's say it was ice cubes in your own house, okay? And you knew that you had left the glass with the ice cubes in it last night, right? Like you knew I left it, you know, on the counter, and now it's tomorrow morning, and I can go like, well, those ice cubes are as old as like last night's at 7 p.m. You could know that how? Because you observed it. But radiometric dating or radioactive dating, no one's observed anything other than like this picture. And they're trying to determine the age of something that they never observed simply by looking at this picture and saying, well, you know, ice cubes tend to melt at this rate. Well, yeah, they tend to melt at one rate when it's really hot and another rate when it's really cold. Amen or no amen? Right? Like that, like we know this. Yes, we know this. Well, another way that you want to think about radiometric dating, and just stay with me a little bit. Come on, you guys go get your coffee and your sugars and whatever. Just stay with me because I want us to understand this because this is what your kids are being taught. Here's another way that they think about it. So elements decay, right? They break down into other kinds of elements. I'm only going to give you one example. Uranium, you heard of uranium, right? Uranium, and don't say vibranium. Okay, this is not like Black Panther stuff, okay, whatever. Anyway, okay, so uranium breaks down into lead. We know lead, right? Uranium breaks down into lead. Uranium breaks down into lead. So see this little image of this hourglass? Imagine, if you will, this top sand or dust or whatever you put in grain, whatever it is. Okay, so just imagine this is uranium, and over time it decays and it becomes lead. Yes? Becomes lead. Becomes lead, becomes lead, yes? All right, so this is what radioactive dating sort of looks like. They look at a rock and they say, oh, well, there's all this uranium up here and there's this lead here, and we think we know how fast this becomes this, and therefore we can tell you backwards how old it is, right? Sounds good, yes? Like, sounds like it makes sense. Here's what you don't know. Have you ever played a game? Have you ever played a game using the timer as a little hourglass? And if you're like me, well, I don't do this, but I was going to make a joke because it sounds funny. But when you're like me, what do you want to do to the hourglass when it's the other? Ah, Bella, honesty, confession. Bella's back there. She's like, shake it, right? Because if you shake it, what happens to the stuff inside? It falls at a faster rate, doesn't it? It falls at a faster rate. So 3 problems with radioactive dating. 3 problems with radioactive dating. Number 1 is it assumes that this all happens at the same rate of speed over billions of years. It happens, so their assumption is that it happens at the very same rate of speed over billions of years. It doesn't take into consideration that Bella may be back there going, a little shaky, shaky, okay? They don't assume that. They assume it happens at the very same rate over billions of years. Number 2, no outside influence on this process. So not only did Bella shake it a little bit, you don't know, but Mo came in when you weren't looking, when you went to the fridge to get some ice cream. He opened the top and he poured some more sand in it. You didn't see it because he's slick like that, but he poured more sand in it. So it's actually got more sand in it than you thought. And then the last thing, see this statement, no daughter elements at the start? Where are we at? The uranium in the top is called the parent element, okay, the parent element. The lead in the bottom is called the daughter element. Yes, we with me? Okay, parent at the top, daughter at the bottom. The scientist looking at the rock assumes that all of the element was the parent element to begin with. It assumes that. You can't prove that there wasn't some daughter element already in the rock at the very beginning of its formation? How can you not determine that with certainty? Because you weren't there to see it. So I'm gonna give you another way to think about this. All right, I don't want to raise of hands because because this could be embarrassing. But how many of you, just think to yourself, have ever gone for a jog and you were fired up to begin with, and you started off and you're just moving, bam, bam, like you're going for it, and 4 seconds later, okay, you guys get me? Right? Like you start off and you're going for it, and then literally within seconds, the lungs hit and the legs start to burn and you slow down. If I were to track your speed in those first 4 seconds, and then you were to tell me you ran 4 miles, stay with me, guys. Would I not miscalculate how fast you ran those 4 miles? Because I didn't know at second number 5, you were already walking. Got me? Now watch this. At the end of runs, have you ever seen when somebody's running and at the end of their run, they speed up, like they know they're like 100 yards away and they pick up at that last pace, right? And if you were to get that pace at that last 100 meters or 100 yards, if you were to then calculate the 10 miles they claim they ran, would you accurately calculate the time? You wouldn't, because you're using their fastest time. Now, let me give you the flip side. Have you ever seen somebody who's about to die in the last second of their run, and they're running much slower than they were running 2 miles earlier? If I were to take just the last little bit of their run when they're completely exhausted and they're barely just trying to get to the finish line, and if I were to take that speed and calculate it over their whole run, would I miscalculate? I would miscalculate. That is the problem with radioactive dating. You have no idea how fast it used to be billions of years ago. You just look at its rate of speed today, but you don't know what you're looking at. You may be looking at the sprint at the end or the feeble attempt to just try to finish at the end. You have no idea what it was like millions, billions. You don't even know what it was like 100 years ago because you weren't around to measure it. Does it make sense? That's the fundamental problem with radioactive dating. I'm gonna give you one last little example. Mount St. Helens. If you're a Christian and you don't know about Mount St. Helens and its eruption in 1980, then you need to know. You need to know because so much was learned about how fossils are formed, about how rock formations are formed, etc. So I'm going to give you one last thing and then our lesson's done. So Mount St. Helens erupted in 1980. By 1986, all sorts of new life type things were already taking place 6 years later. Scientists grabbed some of the hardened lava and some of the samples of what it had become, right? Some 10 years later. So they had started to observe this stuff in 1996. They began to experiment on dating it. The laboratory estimates were that this thing that was 10 years old was being dated in the 250,000 year range. Some estimates as old as 1.5 million year range. It was 10 years old, my friends. 10 years old. How do they know it was 10 years old? Because they saw it, right? Scientists started to recognize the formation of this particular set of rock in 1986. They began to test it from a dating standpoint in 1996. They knew it was 10 years old because they had observed it. And yet when you take it to a lab and you use this radioactive dating method, you get hundreds of millions of years or whatever. You know what I mean? Like, I'm joking. It's partial millions of years, but it's not 10. It's not 10. I say that to say this. Your kids are being taught lies in their classrooms, in their science books. Why? So that they can be told other lies about how they got here. The reality is they got here because they were created by an all-knowing, all-loving God who has an eternal plan for them and a purpose for their life and wants them to come home with him to live out all eternity in heaven. But that doesn't mesh with a godless society that we too often live in. And so they play with the textbooks because they once taught your kids that the A, B's, and C's work. And they taught them that the 1, 2s, and 3s work. And then they try to stretch it into this working, and it just doesn't. Why doesn't it? Is it because Brandon has a blind faith? No, it's because the evidence argues against the things that they're taught. That's your lesson.